Chapter 12, File I/O. Here's the slides for Chapter 12. It's going to go through all those concepts we just saw. The first one being advanced file operations. File operations. File is stored in the hard drive and disk drive. Permits to read and write to files just like you can to memory. Use the memory applications. Why would you use a file and not just leave everything in your function? Any ideas? Why are files useful? Oh, so you can't steal your code, okay. Tell me more. How? You can't change the file? Okay. Some kind of security thing. All right, so when you get a better idea, let me know. Anyone else? Why use a file? It's more organized. So I have used files to input to a program. So generally, so far, we've used the CN, right? You type it. And the typing can be really laborious, especially if you're typing the same thing again and again and again and again. It'd be nice to store that typing somewhere so you don't have to type everything over again. So I use files if I need persistent data. What's persistent data? Do we have it in this slide? We do not. If I turn my program off and it terminates, do I forget all the values stored in the variables in that program? Are they gone? Poof. Or are they saved somehow? If I run my program again, does it remember the old values? No, they're gone, right? They're gone. If I put those values into a file and run my program again and read from the file, are the values still there? Are they in the file? Can I get to it anytime I run my program? Can I shut my computer off, turn it back on again, and the file's still there? Yeah. Files are permanent, right? They're persistent data. So if you ever want to need something for persistent data, maybe you have a leaderboard. So you've made your own tic-tac-toe game. You're counting how many times you beat the computer out of how many games, like a proportion. And every time you beat the computer, you add one to your leaderboard. Yay, beat the computer again. In order for you to keep that leaderboard over multiple runs of your program, you'll need to write that leaderboard into a file. So a file is persistent, and it's useful, in fact, almost crucial. I don't see how you can write any real program without saving something to a file or reading something from a file. So file I/O is crucial to a good program. Little simple things we've made so far disappear when we turn the program off. Now we can keep stuff forever on our computer. Well, pretty much so. File is a set of data stored on a computer, often on a disk drive. Oh, I think I read this. You read and write to files used in many applications. Requires F-stream header files. So using files, we can use the F-stream for file stream. Now we have used IO-stream. We see it over here on the side here. And IO says input-output stream. And one of them is cout, which allows us to print a stream of characters to cout. So cout is an output stream. It just takes characters and throws them to standard out, which happens to be this terminal down here, right? We can see it down here, Chapter 12, File I/O. And so an F-stream object is a stream, so a pile of characters, just like our cin and cout, but it writes or reads from a file. So we're going to use syntax very much like we use cout to write into a file, and we're going to use syntax very much like cin to read from a file. Now, an F-stream object for a file stream object can be further differentiated into different kinds of F-stream object. We have IF-stream object for input files, OF-stream object for output stream files, and F-stream object for both input and output at the same time. And then, of course, we can use our extraction operator to grab information out of the file. We can use our insertion operator to put information back into the file, and we can look at the end of file member of a stream to see if we have indeed found the end of the file so we know to stop reading. F-stream object can be used for either input or output. Must specify the modes when we open an F-stream object. It's going to take a flag in or out to tell us what kind of reading or writing we're going to do. You can put both flags in at the same time with a logical OR, which we see right here. Now, I haven't taught about logical OR. How many of you guys know what a logical OR is? I'm sorry, this is a bitwise OR. Bitwise OR. No idea? All right. So all I'm gonna we use here we're gonna use logical OR to combine multiple flags at the same time, and a flag is just ones and zeros. So here I have I might define I'm gonna do a full flag. If I have a set of flags, this set of flags is on, so this set of flags can do the like zero off, and I add these bitwise and it was true and false and true. So our bits are either true or false, and I can add and that's just either one is now they're both on. And so we're pouring them together, bitwise over, and that will turn both of those bits on, and the bit this tells you this this is the one putting a flag or can and can't do. On the bottom here, we have combined with an open call here, opening an F stream object to do both input and output. Here's all the flags we have, or so many of the flags. App means append. Append will open a file and write to the very bottom of the file, doesn't overwrite. Whereas input is input mode, opens the file, overwrites the file. Both app and input will create a new file if none exists. 8, I have no idea if 8 does. Let's see. If the file already exists, the program goes directly to the end of it. Output may be written anywhere in the file. So it's like append, but anywhere you want to. Binary writes it as binary, so it writes the bits rather than the ASCII characters. If you don't do binary, it writes ASCII to the file. If you do binary, it writes the bits to the file. So you can put ints in there, you can put all structs in there, and you don't have to worry about it. But you do have to know the format of the file, or else when you read those bits back out, you ain't going to know how they go. We talked about input and output already. Trunk, the file already exists, its contents will be deleted. This is default mode by iOS out. So if I open it for output and write to it, it's going to overwrite it. And all the contents of the file will be deleted, and we'll get a brand new file the same day. All right, so here's an example. F-string, let's try it. Are they printing anything here? We're printing the numbers to it. And we're doing this for input and output. And we have two files, one called input.txt, one's called output.txt. and I grab a number out of the in file and put it to the out file. And these are ints. So we're going to need some files, and we can try this out. So let's try this out. I need an F stream. And we'll call this one's called in file. And when you create an in file, we're using a constructor here, which you guys don't know about. And the constructor sets up a brand new in file by setting some of its values. And so one of the values is the name of the file, which of course doesn't exist yet. And the other one is that flag we saw before. Input means we're going to open this file for input. So we're going to read from it. Open for reading. And the other one, also an F stream, we're going to call it out file. And its name is output.txt. And we're going to open it for output. And this is going to overwrite what's there. We make a number. We've made numbers before, ints before. We have a for loop. And inside the for loop, what we do is we read from the input file. That's just like cin, right? We've used cin before to grab an integer from the stream. Here we're grabbing an integer from the file stream, and then we write to it, to the out file. We're just moving numbers from one file to another file. Well, not moving, copying numbers from one file into the other file. Then we close both files. If you open a file, it's good form to close it again. Now, when we try to run this, it's going to fail because the input text file does not exist. When it fails, it doesn't do anything. So it'll look like nothing happens. We got an error. It says in file, but incomplete type. So it doesn't know what in file is. So we need F stream. Build. It does. Voila, it's working. And when we run it, it don't work. It don't do diddly. So it runs that, and Norton says, I'm doing my stuff. And then we should see an output file somewhere. And in my file system, no files exist. So let's create an output file and write to it instead. So instead of opening the in file, we're going to just turn this on. And instead of reading from the in file, we're going to just turn this on. And instead of writing num to the in file, we're going to write the letter I, which is also an int. And then since we didn't open the in file, we don't close it. And this one should actually run. It says warning, unused variable num. That's fine. Run it. And it ran. And notice over here in my file, I got a brand new file called output text. And we double click on it. There are the number. Oh, it's ugly numbers. Blah, 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 989898. Let me check my code, make sure I'm doing it correctly. Oh, we're printing the... It's not printing the character, it's printing the integer value. Oh dear, okay, how can I change this? It should convert it. This is a stream. How about an end line? Nope, same thing. So I don't know why I'm getting those weird numbers. I am getting a file, but I'm getting weird numbers in it. We should be able to look at the file and see what's in it. Let's try something different. Comment the whole thing away and write to this out file. Hello world. Hello file. There we go. This is tiny. So how do I make this bigger? I don't know. So you're gonna have to take a little while to find that so I can make that bigger for you. So right now, you can't really see it, but it says hello file. See how it says hello file in the output file? I just wrote that. So let's put the numbers 1 through 10 in here. I'm going to rename it. We'll call it input.text. And then we'll uncomment these other bits here. And see what happens. All right, so notice I just have an input file, then the input file are the numbers 1 through 10. And if I run this thing, Norton's happy with it. Nothing happens. Lovely. So something's wrong with my input. It's not reading from the file. I don't even know if it's even finding the file. Open for reading. Did I finish running? It did finish running. It says it worked fine. And yet there's no output file created. Maybe we should print the num to the screen. See if this works at all. Found the numbers. Look at that. So it found the numbers. It read them 1 through 10. It's just not writing them to the out file. So I need an output file called output. There it is. It worked. And there's the numbers 1 through 10, all in one row. So it worked this time. I don't know why. So it read from the input file and wrote to the output file. And that's what file IO does. So now I can read and write numbers to a file system and let them sit there for a while. All right, next one. Two different kinds of F streams. We have an IF stream for input. Files cannot be written to, so it's like a safe reading file. Open fails if the file does not exist. An OF stream, open for output only. File cannot be read from, only written to. File created if no file exists, and context erased if file exists, unless you do the app. You do the app, then it will add to the end of the file. This is the basic file I/O. File output formatting. Same techniques with file stream objects as with cout. So we can use show point, set width, show position, etc., requiring IO_manip. So we can use IO_manip on any stream, including a file stream, be that an in-file stream or an out-file stream or just a standard file stream. Here's an example of using them, which I will not copy because we've done this data formatting before, and this also formats the data. Passing file stream objects to functions. You probably guess how they're passed to functions. Are they passed by value or by reference? Reference. Why? True. And an F stream has things inside it that change, such as the position of the reader in the F stream. So I'm reading one at a time from the lines. We saw that in my code. Right down here, I have a for loop, and each time I run the for loop, I read the next bit. It has to remember where it's last read from. So when I'm reading from that in file, the in file itself changes. When I pass the in file to a function, I need to pass it as a reference. So let's find out. We're going to make a function to do this in and output stuff. Void do in out f stream ampersand in file comma splice f stream ampersand out file semicolon. So here we have a function taking the two file streams in and out. You can put the function again down here. 1, 2, 3. Control copy to the bottom. Control V, and turn that semicolon into open and closed curly squiggles. Then we grab the code we want to use and stick it in the middle. The code I want to use is this one right here with the num and everything else. Control X. Go to my new function, Control V, stick it out. And then in the middle here, we're going to call, whoopsie, right here, do in and out with the in file and the out file. And if everything works this to work, I can throw away my output file. So I can delete this thing. Where's delete? There you are. Delete output file system. Yes, please. All gone. And then we can run it again. Control save. Run it again. This should do the exact same thing it did before. Control save, control build. No errors. Control F11 to run it. It ran, it printed. Close. Is there a refresh I have over here? Let's see. Nope. Why doesn't it show up? A refresh? Dots. No refresh. I do it twice. Does it show up the second time? How come it didn't show up? Project Explorer. Is there a resource? Search project? A refresh? File? I don't know why it doesn't show up the first time. I run it again because it looks like it worked. Still nothing, right? I don't see this output file showing up. Why? Where did it go? It's certainly finding the numbers. It's printing the numbers. So it is in here. It's doing this, but it's not doing this. You know, it's passed as a reference. And I don't know why I don't see it. Let me open this up in the File Explorer itself. I just want one of these, not a whole bunch. Here we go. This is chapter 12. These aren't in alphabetical order. There we go. There it is, output.txt. So it shows up here, but not over here in my file system. There must be a refresh here somewhere. Is there a refresh? New, blah, 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 copy, delete, source, import, export, refresh. F5 is a magic refresh number. There it is, output.txt. Double click on it. There's my numbers 1 through 10 again. So I needed to refresh, and I figured out how. F5 is a magic number. Okie dokie. So notice again that we are now passing these stream objects to a function by reference. All right. We could probably pass it by copy, right? Pass it by value. The output file probably by value. But then this one over here would be a copy. I wonder if that works. Let's see what happens. I'm curious. So let's get rid of our output.txt. All gone. And then we're going to run it again. Oh, it's mad. And it says, undefined reference to do input in it's mad because I changed the ampersand here, changed the what do you call this? The signature of the function, but not up here. That's why it's mad. They have to match. I get another error, and this one says use of the deleted function and delete the function. I think it's wrong. That's a weird error. Same error. So it's mad at it. And the error it's saying is use of deleted function. And the function is standard basic F stream, constant basic F stream, character traits. I don't see the function here. It's a constructor. It's a constructor. So it's using a constructor and saying the function is deleted. Strange. So it doesn't like it. I don't know what the heck the error is. Never seen that error before. So it needs it to have the ampersand or else it doesn't work. There it goes. All right, next. We just did this. Passing file stream objects to functions. As you see, pass file stream objects to functions. Be sure to always pass file stream objects as reference. I tried without and it failed on me. And here's an example. We just saw my own example. Next. More detailed error testing. We have some, what do you call these? Status bits. Just like CN broke. Remember we broke CN and fixed it? Our F streams have broken bits too, which we have to look at. But I have some new bits. We have this EOF bit, which is end of file bit, and that's set when the end of file is detected. The fail bit we've seen before, hard bit, set when error occurred and no recovery. Maybe you're trying to write to your file system is full. Bad bit means any of the bad bits have been set, and good bit means that it's still good, and none of the bad bits have been set. We have some functions to test the bits. EUF returns true if the end of file bit is set, and so on. We've seen these with CN. The exception, no, we've seen the EUF bit too with CN. Here's an example using the different bits. It just tests to see if the bit is set and shows you what's there, and then calls file clear. Can you guess what clear does? It says clears all the bad bits. Have we used clear before on something? On CN, remember when we broke CN? We used clear to unset the bits. Same thing here. So clear will clear all the bad bits, but it doesn't empty the buffer. And so if the same circumstances exist that caused the buffer to fail the first time, the buffer will fail the second time, even though you've cleared all the bits and said it's a good buffer, but you haven't fixed its state. Member functions for reading and writing files. We can use getLine to get a whole line. So here, in this function, we're using the extraction operator to get an integer from the file. The file is written. If we look at that input file, the file has a whole bunch of strings. Oh, these are too tiny. How do I make these bigger? Let's see, is it Control Plus make it bigger? It does, look at that, what a deal. These just have the letters 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 0. So we have words in here. So these are ASCII characters, and we're getting them and converting them to an integer, but we're leaving the new line right there for the next read. So the new line gets stuck in the buffer. And every time we read it, that new line doesn't move. But we could use getLine like we've done before. I'm going to make this smaller again. Oops, too small. Uh-oh. I broke it. Control Shift plus. Much better. There we go. I think that's where we're at. All right. We use getLine. Get, does everyone remember what actually it says? Gets a single character, reads a single character, and put will write a single character, right? We haven't seen put before, but we've seen get. Where's it get ch? We're seeing. I think it's get ch. Or is it just get? Don't remember? Seeing has some kind of get that we can use. And here we have get again. 3 arguments. We have a getLine function has 3 arguments. The stream object, you're going to get stuff. The name of a variable you're going to put the stuff into, usually a string. And the termination character you're looking for to terminate the getLine read. Without the T, if we just ignore that, that termination character is the new line. Which is what it says here. And we've used this before, getLine. So this is just the getLine again. Here they're using getLine, name of the input file, and so on. Murphy text. Although we do a test here. Notice if name file. If file was successfully opened, continue. So we can test to see if a file is open by just asking for the file itself. So the file will be a null if the file did not open properly. And the null, when we if it, is just like false. So here, if the file actually did open, we can do stuff with it. And so we can put the name of the file in the if statement. Get and put reads a single character. And we can combine that get characters in a while loop. Can have more than one file open at a time. Files may be open for input or output or both. You define a file stream object for each file. Each one gets its separate object. So your example using multiple files. We had one over here where we used 2 files, in file and out file, both open at the same time. Here they're creating an output text file, getting some information from the user, and then opening on another file the user asked to open. Then they go into this file, if in file, they get a single character, and while in file is true, so we read a character and there is indeed a character there, in file is still true, we're putting that character uppercase into the output file and getting another character. We keep going until we run out of characters to put to uppercase. Once that occurs, in file is then blocked, the bad bit is set, we do a while in file fails, then we close both files and the conversation is done. So in this program, the user is copying the contents from one file into another file and capitalizing them. You want to try it, or shall we move on? So that people are falling asleep. So I'll go faster. Binary files. So far we saw that files without that key flag binary write in ASCII. So again, I read an ASCII, I write an ASCII. Read an ASCII, write an ASCII. Both were opened without the binary file thing. But we can write in the binary file. But notice how we have to pass this thing. We have to create a character pointer, which you guys don't know about yet, and write a byte at a time. So character star is a string, a C++ string, C string, which is a null terminated array of characters. But this is a pointer to it, so we don't know if there's a null there or not. We pass it the address something. We also pass it how many bytes to write, size of num. So we do this, we can read this many num bytes from a file. You can also write to it. So using read and write to read or write to it, and then writing or reading to it as binary. So let's try this one. Let's see if we can write binary here. Output or iOS, what was it, binary or just bin? Binary, binary. So now output file is a binary file, and we have to do this reinterpret cast. We can't do the out file gets num. Instead, we have to write to it. Write, reinterpret, cast. This is an int. Oh, character star, sorry, character star. The address of num, and we have to say how many nums to write, or how big is num. Num is size of characters long. Did I do it right? Let's find out. Wah, wah, wah. Expected a closed curly brace, so I have something extra here. I think it's here around ampersand num. No, size of num, close, close. What's missing? Out file dot write. Reinterpret. Did I spell it right? Reinterpret. It did. It's orange. Character star. Ampersand num, comma. Size of num, close, close. Expected before ampersand. Where? Here? Does it go around ampersand num? Yep. That's the change in syntax from the slide to what is currently being written. I think this is C++ 11. All right, let's see what happens. Let's get rid of our out file. I don't see it. F5 was like, nope, nothing happened. F5? Nope. Function F5? Nope. Did I delete it already? Let's take a peek. Yep, it's gone. Deleted already. All right, let's run this again and see what happens. Nothing to build. Let's run it. Goes. All right, we read from the in file correctly, the numbers 1 through 10. We are then absorbing them into an integer and writing this integer as bytes. The output file should exist now. Let's see if it does. Nothing. Did it even write? There it is. I don't know why it's not showing up in my thing over here. Is it just F5? Nope. Function F5. There we go. And we double click on the output file. It's full of garbage. See that? How much garbages do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 bits of garbage. Oh, 9, 10. I guess there's 2 blank garbages there. So it wrote garbage. So this is a binary file. We're trying to read it as if it's a text file. And it wrote it as binary. But we should be able to read from that if we read it as if they were nums. So let's make another one. And let's open this one for both input and output. So we can do 2 things at once. I don't know if this can work. I need to close it and output it again. Do I out B, binary, do I out B. Let's make another one. And let's just move that binary bit to the input. close, close. Fstream in B file output dot text, comma, ios in or ios binary, and we have a new output file in out file, capital F file this time, out file A for ASCII, out file B, close out file B, out file A, output a.text, comma space, ios out. Do in B out, output.text, sorry, in B file, comma, out file A. All right, in out, I think it's out B here. B, doing out B, doing out B, and out B. Let's copy the whole thing here. Copy, paste it again for the other one. B, and this one is called do in B out. Do in, let's see, here it is. Do in B out. And instead of the in file, we're going to do, was it read, right? In file dot read, reinterpret, cast, character star, ampersand num, comma, size of num. And then down here, we can go to our old writing, which was outfile.write, or outfile gets num. So let's take a look at what I'm trying to do here. Now I have 4 F streams. We have an in file, which is input.text. We have an out file, which is output.text, which are writing to binary. Then I close them. Then I open up new files again. This time I open up output text. I create a new file called output.a.text, which I close. Notice I'm writing to it binary for output file B. That's output text is binary. Then I read from it in binary and write to it in ASCII again. So when I'm done, I should see 2 output texts, one in binary and one in ASCII, and we can compare the two. So let's get rid of output text. It's going to change. And let's save this, see if it compiles. It did. And let's run it and see if we do indeed get 2 output text files. One in binary and one in ASCII. Uh-oh. Big god awful numbers. Interesting. So it didn't read properly. Let's take a look at our output files. We got output A, but I don't see output. Where did output go? We got these weird numbers in it, so those are ASCII written. So that's an ASCII file. It's supposed to be an ASCII file, but it didn't read properly from my input or my output.txt file. Did I do the right thing? Let's take a look. Maybe I read the wrong file in here. In B file, it should be output.txt. Output.txt was closed. I'm reading it for input Oh, here we go. iOS in or out. Did we get rid of the in part? Maybe that was the problem. Let's throw it away. What did I run it? File looks safe. I am running it. I don't want to run it. Stop. Output A, go away. Where do we have everything? Oh, there's our output text. Throw that one away too. Do I have everything? Looks like I do. All right, let's run this again, see what happens. Looks like it worked that time. Numbers 1 through 10 stored as in binary. Read from a binary file. Numbers 1 through 10 again, this time stored as ASCII. I should have two outputs, one output text and one output A.text. And I do. Output text should be in binary. Got awful garbage. And output A.text should be in ASCII again. There we go. So this is how to read or write from both ASCII or from binary. And again, we're using the read and write commands to read or write a number of bytes from a file. And our trick here is reinterpret cast to a character pointer that will read or write 1 byte at a time. And we go to a location in memory. In this case, we have num, which is an integer, which has 4 bytes. And we're going to read or write those 4 bytes. So it just jumps to memory, grabs the ones and zeros, and sticks them in your variable as if it's the type you declared. All right, that one's done. Where are we? 7:28. 6:30, 7:28. It's almost time for a break. How are people doing? We can do one more? This is creating records with structs. Oh, so here we're doing writing as a binary file. Here we're writing a struct as a binary, and we should be able to read it as a binary as well. So we can put a whole struct into binary with the same way we're putting those ints into binaries, right? Struct is another data type. In this case, test score is another data type, and we can dump a whole struct as a binary glob into the test, or the file. There you go. They don't say what they call the file. Random access files. Here's a good spot to stop and come back to. So let's take a little break. It is 7:30 now. Oopsie, it's about to die on me. Take a little break. Come back in about 10 minutes. And we'll do this next bit. Let's back up a little bit. I'm going to shut this down.